Let us see one example. The given sentence is the dog barked, and the words, individual words present in the sentence or the tokens are the dog barked. So here the main aim is to find out specific tag for this word barked. So for that we are assuming two tags. One is verb and other one is noun. So we are assuming that this word belongs to either of the two POS tags. Step 1 is define feature functions. Here X is the input. So input can be word, previous word, anything. So this is the context. And Y is the output. So that means the tag which we are going to give for the input word. So these are various features. So you can see the description also. So our current word is bark. And say suppose the tag assigned to that is verb. So we are assuming that as feature 1. And we are taking second possibility, like current word is bark, and it may be noun also, because we are assuming initially as we assumed this word barked as it can be either a verb or noun. So we are taking both the cases. Bark and the tag is verb. Then word bark, tag assigned to that is noun. So that is the second possibility. Then you can take previous word also. So previous word is noun, dog, and the tag is verb. So if you take that, so previous word as well as the tag. And the fourth one, say if the word ends in ed. So this bark ends in ed. So we are taking only that part. And we are assuming the tag assigned to that this word is verb. So that is one more possibility. And we are taking the length. Say if the length of the word is greater than 5, you can see the total number of words, total number of characters in this word is greater than 5. So we are assuming word length greater than 5 and say the tag assigned to that is noun. So by taking different possibilities, we are going to check which of them fits well for that particular word. Step 2 is feature values. So initially we assumed that this tag can be either verb or noun. So we are taking the first scenario, assuming that the tag assigned to this is verb. And take the features. So what is the feature? Current word is bark, tag is verb. So in that case, as this tag, we are assuming this tag also as a verb, it fires. And the value 1 will be assigned to that feature because there is a match. You can see the word barked. We are assigning POS tag verb to the word bark. As we are doing for the verb tag only, this function, this feature fires and the value 1 will be assigned to that. Let's move on to the second feature, F2. So here what we are assuming, so we are giving POS tag noun to the word barked. But in this case, we are telling that verb is assigned to barked. So there is no match. Here we are considering it as noun, but here we are checking for verb. As there is no match, this feature won't fire and value 0 will be assigned to that. Then moving to F3. F3 feature is we are taking the previous word dog and the tag is verb. So here we are doing for the tag verb. Previous word is dog. So yes, it fires and value 1 will be assigned. Similarly, for the fourth one, word ends in ed and the tag assigned is again verb. So as we are doing for verb, again it also fires and the value 1 will be assigned. Then the last feature is F5. Here again we are giving the tag as noun, but now we are doing for verb. So as this verb is not equal to noun, it won't fire and the value 0 will be assigned to that feature. So this is how we'll match this particular tag with all the features designed before. Then take the second possibility, say the tag is noun. In that case, move to the first feature. So what is our F1? We are assuming tag assigned to this is verb. But here we are taking for noun. So it won't fire and value 0 will be assigned. Whereas for the second one, we assume that the tag assigned to this word is noun. And here also we are considering that noun only. So it fires and value 1 will be assigned. Then for feature 3, F3, for F3 as well as F4 also, we considered only verb as POS. But here it is noun. So both of them, as tag is not equal to verb, they don't fire and value will be 0. And for the last one, again, we assume this value as this tag is noun. So here it fires. And also condition satisfied. The number of words, the number of characters in barked is 6, which is greater than 5. So the value 1 will be assigned to this feature. Now we need to give weights, assign feature weights. So these are the weights which are assigned randomly during training. Now compute the scores. So we already saw the formula for all these things. For computing scores, we need to multiply lambda I, that is a weight, with this feature value. So 1.5 into 1 for verb we are doing. So this one, 1.5 into 1 plus 0.7 into 1. So why we are not taking this? Because the second feature value is 0. So 0 multiplied with anything is 0 only. So no need to calculate for F2 and F5 separately. You just do only for 1, 3 and 5. So multiply 1.5 with 1, 0.7 with 1, 1.0 with 1. So 1.5 with 1, 0.7 with 1, 1.0 with 1. So score for verb is 3.2. Now take the second POS tag, noun. So only 2 features matched with this noun. Here you can see we have 3 zeros and 2 ones. So just focus on the second feature as well as last feature. Multiply only those two. The second feature 0.5 into 1 plus 0.4 into 1, which gives you 0.9. And after this, calculate softmax probabilities to get the values between 0 and 1. So for this, you can see the formula. You need to calculate the probability using softmax. So take these values 3.2 plus 0.9. So which gives you some value approximately like 26.99. Now find out probability for both the tags separately. So take the value 24.53 for this score verb and divide that by the total value. Similarly for the noun value is 2.46. Divide that by the whole value. This addition of these two values, you will get the summation. You need to divide both the values by 26.99. So from this, we got the probabilities like this 0.91 and 0.09. As this verb is having highest probability 0.91, the tag assigned to the word barked is verb. So in this way, Based on the probability, the tag which is having highest probability will be considered and that tag will be assigned to the word present in the sentence.